Well, good evening, everyone. Okay, let us begin today's problem. Okay, now, so this is a problem on friction. Okay, so this is a problem on variable force on a friction. Let us see what is this problem on. A force which increases uniformly from 0 to a maximum value of F. Okay, 0 to F, it is increasing. Okay, I have an object of mass M. You are applying a force. And this force is not a constant force, okay, which means, let us say, for example, you are applying a force of 0 Newton, 0.1 Newton, 0.2 Newton, 0.3 Newton. You are kept on increasing like this, okay. The object does not move until it exceeds 0.5 F, until you exceed 0.5. See, whenever we say, why I applied a force of 0.1, 0.2, 0.3, and so on, if the object does not move, that means there is an opposite force here, right? Frictional force is here. Okay, thus the object does not move. So therefore, if you apply a force of 0.5 times F, only then the object is started to move, which means now this is your what you call a sliding friction. Okay, so you applied a force of so much, it has crossed the threshold. Now the friction is unable to hold the object and says, okay, Are Baba, I can't hold you, you better go away, right? So it started to move. Now, as the force increases from 0.5 F to F, now when this object started moving, I was so happy and I started to push it much more. Okay, the force is now increasing. The object moves a distance x. When I keep on increasing the force, I observe that the object keeps on moving and it has reached this point. Let us say the distance between these 2 points is x. I hope you have understood the problem. Now, what is the work done by the force? Now, usually what students do is they find out work done is nothing but the F multiplied by x, final force minus initial force multiplied by displacement. Because we know work done is equal to force multiplied by displacement, right? And thus they do the same thing, but this is incorrect. Is incorrect. I'll tell you why. You can use work done equal to force into displacement if and only if the force is a constant. The force that I apply here is a constant. Of course, x can be a variable, no issues. But this force should not vary. Okay, for a given distance, whatever distance the object is moving, this force should not vary. Okay, but here you see the force is continuously varying. So you should not apply this equation. Okay, but what he has done is fx. You can say, okay, I did not use fx. What he has done is he has used f minus 0.5 multiplied by into f multiplied by x. This is what most of them do, and they get the answer as 0.5 into fx. That's what they do. Okay, this is incorrect. Now let us look at the actual methodology. There are two methods to solve. One is by method of integration. The other one is by the method of graphical analysis. And I always feel graphical analysis more easier than integration. Now let us do with the integration, the graphical part. This is my axis. Let us say this is force axis. This is my displacement axis. Now what happens? At a force F equal to 0, is there a displacement? No displacement. See, the body does not move until the force exceeds 0.5 F, which means 0.1, 0.2, 0.3, 0.4, until 0.5 F. Until 0.5 F, there is no movement at all. The object is at rest only. Then the object moves a distance x in the direction of the force. What is the work done by this force? Okay, now, when you increase the force, see, I can always say I am increasing the force. When I am increasing the force, for every distance, definitely the object will be moving by a smaller distance. For every increase in force, the object will be moving by a smaller distance. So what I do is I draw a line like this, which indicates that I have applied a force, and for every increment in the force, the object has moved a distance x over here. Let me say this is p, this distance is x. And this value is nothing but capital F. This value is nothing but capital F. So now you see, until 0.5 F, the object did not move. Beyond 0.5 F, as I increase the force, the object started to move. Some people can always argue saying that, hey, why should it be like this? Why can't it be a straight line? It's not a straight line because here there is nothing else given to you. So you are assuming it like this. Okay. Now towards it. Now what is it you need? You need to find out the work done by this force. Now what is work done from an fx graph? The area under the curve. Area under the curve. Let us find the area. This looks like a trapezium. Let me say this is OP. Let us say this is A, this is B. Okay. So what is the area of the trapezium? Area of the trapezium is half D into A plus B. Okay, this is my area. And this area should give you the work done. Now half into what is D? D is X. Distance between the two parallels. And what is A and B? A is length of this parallel, B is the length of the other parallel. Okay. So therefore A is 0.5 F plus B is nothing but F, right? Plus F, which should now be equal to half X into 1.5 F, which should now be equal to 0.75 times Fx. Wonderful, right? This is the answer. Okay. So I hope you have understood the concept. In the next lecture, we'll explore something more about the forces. Okay. Thank you.